Hello, everyone. Good afternoon. And today we will talk about the first midterm exam. And I have these slides to summarize what will be covered in the exam. Okay, what kind of knowledge will be tested in the exam. All right. Okay. So the exam will be like covering reoccurrence. And I would recommend you to be familiar with all the recurrence equations for the main algorithms that we have covered, like merge sorts, quick sorts, right? And also you should know what the function of recurrence is, like what is it for? So it's basically a description of the running time. We use the recurrence equation to describe the running time for algorithms, and that algorithm is usually belongs to the divide and conquer approach, divide and conquer families. Okay, and also, secondly, you should be able to know you should know the way to draw recurrent trees based on the recurrence. So actually, we have. In our slides, we have several examples showing how the recurrence tree can be drawn, even if the splits for the sub-problem is not like even. Okay, so there can be 2 splits or 3 splits or more splits for a recursion tree. Okay, for each node. And you should be able to derive a tree from the recurrence. Okay, and also, like you should be able to know how to derive the recurrence. I think you have done this for the binary search algorithm in the assignments. So given a pseudocode that's an algorithm, and a recursive algorithm that includes the recursive calls to the function itself, then you should be able to like write the recurrence equations out of it. And lastly, we have a whole chapter about using the master method to solve recurrences, and this is definitely something you should know about. You should know about the 3 conditions of the master's theorem, like how do you want to compare the 2 components, the logarithm, the polynomial function determined by the logarithm base B of 2 with the other function. Okay. So that's for the recurrence. Next, we will have questions that have pseudocode provided, like a template provided, and there are some missing lines for you to implement the algorithm to fulfill some functions, to fulfill some goals. So you should write the code in the correct formats. Okay, so like those keywords, the for loops, while loops, and the operators are something you should stick with the conventions. Okay, and some technical details about the for loops. For example, we assume that the loop counters starts from 1, which is consistent with our convention that the first element in the array has an index 1. Okay, and also for example, I use this example to show that you should know about the increment step for a loop and how it is determined. So the increment step is not necessarily 1. Like in a for loop, it's basically the default incremental step is 1. But in a while loop, you actually have the option to increment by 2 steps for each iteration. So the loop counter I will be incremented by 2 after each iteration of this while loop. Okay, so for questions like, given this custom value in the incremental step, how many actual iterations will be executed? Okay, so this is something you would need to know about. All right, that's the pseudocode. So in terms of algorithms, I would not like, so let's go to the next slide first, like what will not be covered. All right, so we have first used, have several slides when we talk about the correctness of algorithms. We use loop invariance, which is a technique to strictly prove that an algorithm is correct. But that is optional. That is definitely gonna not going to be tested in the midterm. Okay, and also I will not test a substitution method. I think we have sufficient amount of practice in our assignments, and that's basically why I did not include it. And also the sorting algorithms, which actually is quite a lot of contents from quick sort to heap sort, and including the linear time sorting algorithms. But I found that although it is a big topic, but actually the techniques that we already use in those algorithms is actually not a primary focus for the first half of for the first 1/3 of the class. Okay, so we will not test anything in the sorting algorithm, like including the quick sort, including the heap sorts. Okay, so we are not going to test the heap data structure or any operations related to heap. Okay, so another reason is that I think I had put sufficient practice in the assignments, and I will probably have one question about the sorting algorithms. Okay, in the second midterm, but not in this midterm. Okay, so there will also not be strict proof questions like that will ask you to prove the asymptotic notations, like from big theta to big omega, big O, or small o, small omega. Those will not be tested. Yeah, but it doesn't mean that you don't need to understand them. Okay. So let me go back. All right, and like I would recommend you to have a pretty good review about merge sort and the merge, and then really know about really know about the algorithms. Okay, so and also if you remember question in our assignment 1, there's a question about binary search. So it's a typical type of problem that can have 2 types of solutions, like a recursive versus non-recursive. And I would recommend you to review that question, and it provides some contextual information that will be helpful for you to prepare the midterm. Okay, and that's pretty much I have for the slides. Okay, so now I'd like to take questions, and if you have questions about previous assignments, you can also put it in the chat, and I can talk about those questions, or you can just let me know and turn on your speaker microphone. Yeah. Okay, anyone has any questions, any type of questions? No question at all. Next slide. Okay. Loop variance substitution. Yeah, this is the final slide. Or any general feedback about the course, like the speed, the pace, type of homeworks. Is it too hard, too easy? Yeah, any kind of feedback. Okay, I didn't enable the chats. Let me enable the chat to everyone publicly. Okay. The test will be at the same level, almost the same level as the homework. Will not be particularly harder. Yeah, the test will be on the paper. Like I will upload the PDF file that you need to print, or if you don't want to print it, you can also like look at it, like read the questions on the screen, and you have them worked out on the paper, and then submit the scan for the paper. Yeah. But I leave some space on the question sheet for the exam, so there will be boxes for you to directly fill in your code or to fill in your answers, which will be easier to grade. Let me see what the question next is. We want to go over any previous problems. Yeah. Extra time after advance to scan. Yeah, so for the previous semester, I put like 5 more minutes to extra time after the, like, in addition to the original class meeting time. Yeah, so the test will starts at 2 and ends at like 3:15, but I will give 5 more minutes, like to 3:20, for you to scan and upload. Yeah, I see a question about drawing a recursion tree. Yeah, I can do that. Maybe I can do the homework again, redo the homework. It is open notes. You can read the slides when you do the exam. So there's a question about drawing a recursion trees in the second homework. Probably use this as an example. Share. I think this is a question we have for in a second homework to draw a recursion tree. Right. Yeah. So this kind of currents is a little bit different from the one of a um, like merge sort, like merge sorts, quick sorts, which produce a balanced tree. So this tree is obviously not a balanced tree. So how do we come up with the quantity in each node? I think is something you need to figure out, right? So basically, you can use the substitution, like because the original form is t of n, the function takes the n as inputs. All right, so you can what you can do is to take this value on the right and substitute it into the left. So if you think of n minus a is now the input, so then the equation can be written as n minus 2a plus c times n minus a. Okay. So that's how you get the node values for the second node here. Okay. So well, let me just start from the root node. Okay. So the root node is usually this term. Okay. So all the examples we have shown so far is that we use this term as the root node, because how we draw the tree is that given this full equation for t of n, we would put it into three parts. We put this function c times n into the root position, and we draw two splits because there are two components before, t of n minus a, that is one branch, and the other t of a is on the left. Yeah, and of course you can switch over. You can switch the t of n minus a and the t of a. That doesn't matter. Okay, but next step is something you need to focus on, one of these or both of these two branches, because in this case the t of a is already a constant term. T of a can no longer be splitted. It's a minimal case or it's a constant case. Okay, so there's only an n left in this left branch. So we need to split this left turn or left branch. And how do we do that is to use the substitution method that I wrote this next equation, right? We can simply substitute the value of n minus a into the function on the left, and then the right will be exactly this form. So next, the root, well, the next this node, the c times n minus a will replacing this node after the split. So the c times n minus a will be here, right? Right. There will be two branches as well, t of a on the right and the t of n minus 2a, right, on the left, okay, because t of n minus 2a is here. Then what we can do is to do the next split, okay. But in a typical question, you will not be asked to like infinitely draw the pictures, draw the roots, draw all the nodes in the tree, okay. For example, some questions will be like draw the first 2 or 3 levels or first 4 levels, and you basically need to know what the resulting node is after you have split each node. I think that is the little bit tricky part you need to pay attention to. Yeah. So after you substitute n minus a into the function here, that is the value left to the node here. Okay. So I don't know, does that help with you for the question about recursion tree? Yeah. Yeah. So after we've got the tree, then a common next step is to find the per level summation. Yeah. So in this particular example, we have 2 nodes at each level, right? For example, the level 1, we have C times n minus a plus T of a here. So we can write the summation for this level is this quantity, right? We just put this together. For the level 2, it'll be like this. Level 3, it'll be like this. So basically, the parts that I wrote on the right is the per level summation. And the next step is to sum up all these per level summations. And in this particular case, if we assume that, if we first, without considering how many levels are there, let's just roll down the summation, the total summation, it'll be C times n plus C times n minus a plus C times n minus 2a until C times n minus ka, right? We don't know what k is, but we just use some numbers to indicate this is our last level. Okay, so for the level 0, it is this. For level 1, it is minus a. For level 2, it is minus 2a. For minus 3, it is minus 3a. So if we assume that the tree will terminate at the level k, then the quantity would be C times n minus ka, right? So there's a k times T of a, because for each level from level 1 to level k, there is a TA here, right? And because this quantity n minus ka should not be a negative number, right? We cannot have a problem with negative input size, right? It should always be greater than or equal to 0, right? So so when k is this quantity, then we are basically has the minimal case, has the smallest case, right? So if we combine the equations here on the left, we would have something that can come into this term, right? Because there are k plus 1 CNs, right? And there is a minus the summation of this arithmetic series, okay? So this part is the result of combining all the terms that has a in it, right? There is a minus a, minus 2a, until minus ka. So we can have this term on the left. And if we sum up, use the formula of arithmetic series, it'll be the quadratic term of k's, okay? And we would know that if we replace k equals n over a, and of course there is some sloppiness. We didn't use the flooring term, but it's okay. We can plug in k equals this n over a into this equation. It'll give us the quadratic function of n. Okay, so this k equals n over a also implies that k is just a linear function of n. K is proportional to n, so the total cost is also a quadratic function of n. Okay, so that's why we can guess the solution is big O of n squared. Okay, so that is a example recursion trees, how we deal with the per level summation. Yeah. All right. So you may have already noticed I have a new module called Midterm1 set up on Canvas page. So on next Tuesday, I will upload the PDF file containing the questions for the Midterm1, and it will be released at 2 o'clock next Tuesday. So in this case, I see another question: how is the k found? Okay, so the k is n over a rounded to floor, because each time we have a split, this value, the problem size, the problem size will decrease by a, right? The problem size would be by n minus a, and the next one would be t of n minus 2a, right? And t of n minus 3a. But this cannot be infinitely going on, right? The problem size will be smaller and smaller, but eventually it will hit some minimal value. And typically we should not have a negative input for a question. It doesn't make sense that your input size is a negative number. So like when a minus 2 minus k times a should be greater than 0, right? So the k should be smaller than n times a. Okay, so the biggest value for k is n times a rounded to the floor, right? If we want the input to be an integer number. Okay, so I find a suggestion that sometimes it will take more time than 5 minutes. Yeah, I can extend that time to 10 minutes because I remember that in the previous semester I had several students that had a little issue when uploading the PDF files, especially when the file is a large one with high quality images. Then yeah, that makes sense. Yeah, I can extend the summation time to 10 minutes. So you will have 10 more minutes. 5 more minutes, which is which ends at 3:25. Yeah, 3:25. Yeah, I can do that. No, if you submit it late, say the deadline is 3:25. I guess it's already sufficient for you to submit it. Yeah. But really, if it's just 1 minute or 30 seconds late, I won't treat it as 0. Yeah. Okay. If you can think of any other questions, you can put it in the chat or let me know. I will accept submissions handwritten through some tablet or iPad. Yeah, it can be totally electrical. Doesn't matter whether it's actual done by the pen or paper. No. Yeah, but you got to put your name there. Yeah, don't forget to put your name. I think you could go over question 2C. Okay. Question 2C. Yeah. Referring to this question, right? So the binary search algorithm, if you look at the solution here, if you look at the search, the recursive solution, it's like within this function binary search recursive, right? There is an if and else conditions. So the first if is to check the whether is to check whether the value to be searched is found, right? And otherwise, it will, based on the condition of whether the mid element is greater than the value or less than the value, it will call this recursive call. It will have this recursive call on different parts of the inputs, right? So it's because this else if and else condition means that within each call of the binary search recursive, there's only one branch to go. There's only either one. You should choose either one to go. You should either go through this one or this one. So there's only one resulting subproblem. So there's only one resulting subproblem, okay, which is T of n over 2. So there's no 2 times T of n over 2 as the coefficient or other constants, because there's only either one. You need to choose either one. You shouldn't choose both one, right? Because when you check the mid elements, like A of mid, you compare it with these elements with the target value V. If that element is greater than V, then that means V is somewhere, must be somewhere within the first half, right? Otherwise, it's gonna be somewhere in the second half. So once you choose the second half, you don't need to go through the first half anymore, right? If you are sure about V must be in the first half, then you don't need to go to the second half anymore. So it's one of two options, right? You just choose. You don't need to go through all passes. So there's the coefficient is 1 but not 2 here. Okay. There's no so the recurrence equation will be like this. And basically this 1 means that there's no additional the cost for split the problem is constant time. The cost is basically line 5, right? The only cost is to compute the midpoint, which is just one line of code. That doesn't do anything anything very expensive, right? It's not a linear function. It's just a constant operation. Yeah, I can put the solutions, the assignment solutions online. Yeah, I see this suggestion that is something that I've been considering. I like the way that Jupyter notebooks can be utilized to for you to have a self evaluation, right? I think that's a good suggestion. I'm considering that. Yeah, but the thing that I didn't have programming assignments for this course is that traditionally this course is not a programming language related course. It's more analytical. But I most of the theoretical questions would be hard to answer through pure programming practices. Yeah, but I am planning for a change in the future, but not likely in this semester, that I can like do a hybrid mode. Like I put part of the homework for the particularly for the code implementation assignments. I can put it into like Python Jupyter Notebook that you can fill out the code. Yeah, that is good question. Let me see. Well, let me see. I will consider that. Let me see if I can do any of the assignments in the future as programming practices. But I mean, in the syllabus, I didn't say that we will do assignments, program assignments at all. But I can do a little experiments if you are okay with that. Like for example, in the next future chapters, I put little parts of homework in the form of a Jupyter Notebook. Yeah. Yeah. All right. Sounds good. Yeah. Wonderful. Okay. That's really good suggestions. I see here. Let me see the chat. So if you don't have further questions, then I'm going to end the meeting now. We need to know anything about Strasson's algorithm. No, for the exam, there will be nothing about Strasson's algorithm for the matrix chain multiplication. No. Thank you. You don't need to open Zoom on taking the test. You just take it at home. Yeah, wherever you're comfortable, and submit it on time. Last question on submit. I mean, yeah. Yeah, this question is hard. Is a hard one. It requires some thinking. So I can release this solution, but I don't think our first midterm will be that hard. No, there won't be anything beyond the beyond the content that are listed in the review slides. Thank you. So I'm gonna leave the meeting, and I will upload the solutions for the homework online. Yeah, you will find it on a Canvas. I can create maybe a new module. All right.